So when we're given the sine ratio of 3 over 7, we know that the sine is positive, which means the y value is positive, and the y values can be in the positive y quadrants, or quadrants 1 and quadrants 2. Okay, so the sine values are going to end up in those two quadrants. So when I draw this, okay, the y is my vertical, so it's going to be maybe something like this, 3 and 7 in that position right here. We could also have another position that we have to consider, which is in quadrant 2, and it's symmetrical across the y-axis, and we have 3 and 7 here. So those are two positions, and the sine has this type of symmetry. The sine is y, so it has symmetry across the y-axis. So it says, can you draw an obtuse angle with a standard position angle in quadrant 2? Yes, we can. Okay, so we have our angle here, that's our acute angle, and that is our obtuse angle here. Okay, so this is theta 1, we'll call this, and this is theta 2. So there's always two positions that we have to consider when we're dealing with either sine, cos, or tan. Now, since sine has vertical symmetry, it's going to be in these two quadrants. Okay, across the y-axis could be these two. Cosine is x, so it has horizontal symmetry, so it's going to be, the symmetry is going to be horizontal, so it's going to be across the x-axis. And then the tan is slope, so slope could be in two positions on the opposite sides of the circle. It could be like that with positive slope, or it could be like this with negative slope. Okay, but it can take on two positions depending when you take a look at the slope. Okay, and they are on the opposite sides of the circle from each other. So we want to use this symmetry to be able to find these unknown angles, because the calculator only gives you one of the two, and we have to decide which one we need.